So I bought this forklift the other day, and I've just about got everything lined out on it, except this fan hub that they want $600 for that clutch, for the clutch fan. So I'm going to tear all that apart, and then in this video we're going to draw it all up in CAD and machine it, but I'm going to make a fixed adapter so this fan will just bolt directly to the hub. Okay, so I got the fan off the hub now. Now what I'll do is I'll get a piece of paper and draw out where our bolt holes need to be, the dimensions of everything, the height, all that, and then I can go to the CAD software and draw it all up, and I'll bring you guys along for all that. Alright, so we're going to draw up this part real quick. Pretty simple. So first thing is, we need to set our outside diameter. It's going to be 4 inches. That's the total of our part. We're going to extrude it, and it's going to be 1.15 is our total height of this part that we're making. The next thing, we'll just keep rolling through here. We'll do the back side first, where the fan's going to bolt on. So there's actually going to be a hub here, and our hub is, I gotta look at my dimensions here. Where is that at? Aha, 2.62. Alright. And we are actually going to take this down minus 0.25. I'm going to go down 1/4 of an inch. That leaves us our little hub there that'll hold the fan in. And then we need to go back to here, and we're going to put a through hole that's 0.625 all the way through the part. So minus 1.5, that'll get it all the way through. And that's for the backside where the water pump goes, which we'll get to that here in a moment too. We're going to go ahead and lay our bolt pattern layout for the fan itself, which our diameter for this bolt pattern layout is 3.25. So we'll do that, and then we'll create us a point. We'll add it right in there, and then we want to go, whoa, wrong one. We want a circular pattern. We'll click that point and our center point there, and we want 4 of them. Perfect. We'll do that. Now we'll finish this sketch, and what we're going to do here is we want to make it a tapped hole. We don't want a counter bore on this, and we don't care about a drill point because we're going to go all the way through the part, so there's somewhere for the chips to go. So click on all of those, and it's already set up for us. We want 0.3125, which is 5/16 18 2B. So that's everything we need there. Let's see if it's going all the way through the part. Yep, perfect. So there's our bolt pattern layout where the fan's going to bolt to it. Now the next one that we need to do is where it bolts to the water pump. So we're going to grab this here and give us another circumference. And this bolt pattern layout is, where's my notes? 2 inch. Alright. And then what I want to do here though is I kind of want to put this point in the middle in between the other 2 bolt holes there. And the reason for that is these are going to have a 3/4 inch counter bore that's going to go down into it, so I can fit a socket to get to that bolt, because I don't have Allen bolts the right size that I was hoping to have, and I'm just not going to go get some. I can just make it work. So this is what we're going to do here. Finish sketch. We're going to go back to our hole command, click on all 4 of these, and then we want to change this to a simple and a counter bore. We want 3/4 wide, we want 0.85 deep, and we want our finished hole size to be 3.125. That all looks good. Let's see if that did it. That's got us all the way through. So that is all that side. Now we just need to come over here, and we need one more little thing to do here, and that's going to be, it's got a little hub that's recessed, and it is 1.25, and we'll extrude that, and that, minus 0.1, and that'll fix that. So now we just need to go back and make things look pretty. So let's chamfer that, and we'll do 0.03. That'll get us there. Then this side, we're gonna chamfer the outside edge of this, probably these pockets. We'll go ahead and chamfer that while we're chamfering stuff, and we'll do 0.04 maybe. Yeah, that looks pretty good. And we'll go okay with that, and we'll do one more chamfer here, and that is going to be there, there, and there. We're going to do 0.02. Alright, and there's our part. It's all done. So the next thing that we're going to do is do all the drawing of the toolpaths, and then we'll go to the machine. The machine's already set up. We'll kind of get into some more of that here in just a moment. But yeah, this is the part. So the fan will bolt on here, and these center bolts will hold this to the water pump. So, alright. So now we're ready to make this part, or get it ready to make for the machine. So the first thing we need to do is create a new setup. So here's what we're going to do. We're going to go to a fixed size round disc, because I have a piece of 8-inch that will work, and it's 1.75. It's a bit excessive, but it's what I got, so it's what I'm going to use. Everything else looks good. So this little area here is your work coordinates plane. So this is where you touch off and zero your part out. So this is telling me that you're gonna want to find the middle of the part on the top, and that's where you set your Z. You zero your Z, X, and Y, and from there the machine knows where the part is, so it can do everything how it needs to. So we'll save that there, and then the next thing, I guess first, okay, now we see how much stock we have. I really don't care to. I'd rather take less material out on the top and leave more on the bottom, so it gives me more to hold on to, and I kind of go past the part a little bit, so when I come back and face the bottom off, it looks a lot better. So what we're going to do is we're going to go back into here, and we're going to set our offset from the top, and we're going to give ourselves about 100 thou. That'll be plenty to face it off and make it look nice, and then we'll go into everything else. So the first thing is we want to rough everything we can out. So we're going to, oh well, I take that back. I want to face it down to size, because I can move a lot more material with face mill than anything else. So right here we have our standard library. These are all the tools that are in the machine, programmed, all ready to go. I have all my feeds and speeds already ready. And I'm actually going to, yeah, we'll leave that. We'll drop this down to, no, we'll leave it at 0.6. That's pretty good. Multiple depths. We'll do 20 thou. See what it looks like. Looks pretty good. We're gonna go 50 thou though, and just do a 20 thou. Finishing pass. So, finishing step. I'm gonna do 2. We want to slow this down to about, we'll slow it down to about 45 inches a minute, which is about 0.002 feet per tooth. Alright. Let's see what that does. And that gives us a 2:17 for that cycle time. Something else I want to do, I want to climb mill. I don't want to let it go both ways. I want it to pick up and go back and forth and go the same way. Okay, that has that. So now we want to do an adaptive clearing. We'll select our, there's that. We want to use our 1/2 inch end mill long, this guy right here. We'll use this, and stock to leave, no. I want to take it as much to size as possible. Now here's another thing. I want to drop the bottom of this down minus 0.02. I want to go down 20 thou. Actually, we'll go 40 thou below the part here. That way I know I can get past it when I go to do the other side and finish it out and it looks nice. Step down 1 inch. Hour and 48 minutes. Huh. Well, let's see if we can change some things here. So let's go 5, and then we'll go down to 1/2 inch. Take a little more time out of it, doing it that way, and then we'll change this to 54 inches a minute, and then when we do our finishing, I just want to make sure that my, I guess, stock to leave. Radial stock to leave. Okay. Actually, I really don't care. I'm trying to program this like the part's needs to look nice. I don't care if it has little flat spots. I'm just making it usable. Okay, perfect. Let's see. Making speeds. Yeah, I dropped it down to 50 minutes. It's not terrible. The only problem is, how many, 54 inches a minute? I need it to be about 48. Anything under 50, the machine handles pretty well in a circular pattern. Let's see, 2.8 maybe. It's 50, 2.6. That'll work. Okay. So, in circular motions, it's just happier under 50. So we're good there. That gets us to this point here. I need to do all the holes next. Alright. Which I'm kind of surprised it doesn't do that on this one. But we can bore some holes pretty easy here. So we'll bore that one, that one, that one, that one, and that one. We're going to drop this down to, actually we'll go even slower. Actually, I need to take on, do those 4 in one and the other one in another. So that's going to stop those there. And then we're going to move that up to stock top. Give us a little clearance room there. Okay. So that'll bore those. And then we'll duplicate that. Process there. And all we're going to do is change our height to model bottom minus 0.0. Well, actually, we need to go quite a bit below it. So we'll hold off on that for a moment. Delete those. We want to do that one. Stock top. Okay, good, good, good. And then minus 0.4. Okay. Does that get us below our stock? No. Okay. So let's go below the 1/2 inch here. The reason I'm wanting to do this is for my second. Alright, perfect. Our second operation, so I'll have to pick this part back up. I'll have to grab it and flip it upside down. Well, I want to find the dead center of it, so when it goes and faces it down, when I go to do the other pocket on the back side, it'll already know where dead center is, so it'll just, everything will be golden. Okay, so those are ready. Now we need to do these little holes here for the bolt holes. Which the machine that it's running in does not have rigid tapping, so I'm not going to be able to tap them, but I will be able to bore the holes out, so at least I can do that. I'll have to tap them by hand, which kind of sucks, but it is what it is. At least I don't have to do the rest of this manually. So we want to find us a small enough tool, like a little 1/8 inch end mill here. Got that one. Use it. We want to do the bottom. Perfect. And we'll go minus 0.02. That way we get a little bit below it. Stock top on that. We'll do that. I do want to make sure all these lead to center also. Lead to center. Alright. One more little thing left. We're going to select our chamfer mill. So standard tooling, chamfer mill, and then we'll go here. Choose that. You know what, we're just going to go 100th out. Way. Keeps that out of it. And then I don't like how it's doing that in the corners. Let's see what this looks like in a simulation real quick. Yeah, it's taking the corners right off of it. Okay, so let's change our toolpath then. Let's do this one, let's do that one, that one, that one, that one, that one, that one, that one. Alright, and then we'll do that one. So that looks like. Okay. So it really doesn't like that one. No, crud sickles. Let's see what this looks like. Those corners are still going to be choppy, but I don't want to break my cutter either. I may just leave the outside alone, not do the inner thing. So here's what we'll do. We'll go back to design, go to this, and then we're going to delete all those and just do the outside. Manufacture. Let's regenerate everything. This one's got toolpaths missing. Okay, get rid of those. We're gonna do open chain here. Five. Now let's see what that looks like. I can live with that. That will work. Okay, and then we've still got those chamfered holes to do. So duplicate. Delete all these. both of these, I want to make sure that my linking is 45 degrees and not 90. So 45 there. And I don't know that I'll be able to do 45 on these. We'll see. I hope so. Nope, it doesn't like that. So we'll go back to 90, and then there. So this whole part says it'll machine in 1 hour and 18 minutes for op 1. So that gets our programming done for op 1. I guess while we're here, we can go ahead and set up op 2. So for op 2, we'll do a new setup. We want to do continue from rest machining, and then our XYZ plane. We just want to flip the Z axis, and actually I want to change one more thing. We're going to go to design. We're going to put a sketch plane here, and we're going to put a point right there. And then we're going to go back to manufacturer. And the reason for that is I want to be able to pick my Z-axis up off of this face here, because that's where the face is going to be sitting on the jaws of the vise for op 2. So that way I can set my Z point off of that and find the center of it, and it'll be golden. So now we need to switch this to a selected point and select that point there that we just added. Now this thing's ready to go, and it really doesn't matter where it's at as far as roundness goes, because it's just round holes that it's going to bore out on the backside. So now we need to add in our facing operation, which I'm going to use a face mill just because it moves a lot of material really quickly, and I'm also going to hold it in a holder that will allow me to do so. So generally, if you want your parts to look really nice when it's all done, you would use soft jaws for your op 2, where I'm just building something that's going to work and I'm trying to get it done quickly. So I'm just going to clamp it down in the same vice jaws that I use for doing the roughing, which you'll see here in just a moment. We want multiple depths. Finish step. We want 20 thou. Actually, if we go 10 thou at 45 inches a minute, that's going to look nice. Okay. Alright, gets that down where we want it, and then we just need to bore this hole here out with a 1/2 inch windmill, and then we'll do multiple passes. Yeah, we'll do about 2. Okay, should have us there. Let's make sure. I don't see the blue lines up above, so that means that that's going to crash. So we'll change our work height to stock top. Oh no. We'll go to selection, this face. Okay. That'll get that. Then the only thing... Oh, I forgot to bore those holes on op 1. So these holes didn't get bored all the way through, so we need to go back and make sure that happens. That is very important. So we need to go back to op 1 and then figure out what our operation of attack is here. I guess I could just throw a 5/16 drill in and we could just drill that. So I'll make that to 11, add a drill in, and no big deal. So what we'll do here is, yeah, that will be before the boring. So I want to drill those holes before I bore it out. So here's what we'll do. We'll add a drill, we'll select, and we'll go down to Fusion Library, drill, inches, 23125. We'll grab a drill out of here. Aluminum, has all our feeds and speeds ready. We want to do that hole, that hole, that hole, and that hole. We're going to do stock top. We're going to go to hole bottom minus 0.04, and then we also want to do a deep drilling full retract, and that all looks good. We want to dwell for 2 seconds after it gets down there, so it breaks the chips off. So that'll get us our holes all the way through. We need to edit tool and make sure that's tool 11 now in the post processor. Okay, so that's done. We'll add a drill in, we'll drill those holes, and I want to make sure that goes up here before the boring happens. So I want to make sure the tip goes all the way through too. So we want to add tip 3.04. Okay, that's better. Give everything a good once over. It all looks good. Now after that, it'll bore those. It'll do that. Drill those, or bore those, chamfer those, and then we're on to op 2. So we'll go back to op 2. That's going to face it down the size. It's going to bore that out, and then all we got to do is run our chamfer around there and there, and this part is done. It's programmed. So there and there, and we want our chamfer mill. So we'll select that. And then I want to go 0.1. Yeah, 0.1 if I can. Which I can't because that'll eat into the bottom. We'll go 0.05. That way I keep it off the thing. I'd like to do 40. Ooh. 45, which I want to go back and change that on the other ones. That all looks good. Let's make sure those are 45. So the reason I like doing a 45 and not a 90 is there's no, oh yeah, that's right, I couldn't on that one. There's no start and stop point where it leaves like a little edge, like a little burr. If you do a 45, it comes in and it goes through that part that it already did. It makes it look a lot nicer. Okay, so there we go. It's all programmed, it's all drawn. Now I just gotta zero out the machine with the material in it, set the offsets for a drill, and we'll be ready to make this part and then put the forklift back together. So
So one of the problems with these older machines is that file's too large. So it's too much information for this machine to take, because this is originally a floppy drive machine. Even though it's got an emulator for a USB, you can only have 1.4 megabyte size files. So I'd put it on a different USB. I have to, when the laptop wakes up, put it to the laptop, and then it is going to feed the information to this machine the whole time it's running. But everything's set up and ready, so I'll close the doors here, and once the laptop loads, then I can do what I need to do in here and start the program. this is after op 1, and I think it's turned out fantastic. We're gonna make sure everything fits that I need it to, so while it's in here I can change the cutter comp size and bore stuff out if I need to. So let's see if things fit. Well, here we go. The fan fits perfect on there. All the holes line up, so this side's good. And then also, last but not least, does the socket fit down inside the bores for those bolts? And they do. So perfect. All right, here we go. Part's finished. All right, just like that. Now the fan's back on it. Now it'll be a whole lot better. All right, now the fan's on it. Now it ought to work. So